Well, may I start by welcoming you all and wishing you a very happy new year, wherever you are. Well, it can't be any worse than last year, or can it? We're back in lockdown here in the UK, as many of you may be elsewhere, and I'm looking forward to being vaccinated in the next few weeks or perhaps months. Anyway, welcome to this, the British Interplanetary's 12th live stream event or evening lecture since the first lockdown began. For those who don't know me, I'm Alistair Scott, a past president of the Society, but now as chair of the events committee, I try to keep all our events and activities going. As I said last time, we've got a lot planned for the year. Our big Beyond the Moon symposium on the 12th of April, which is also Cosmonautics Day, so we'll be celebrating that. And it'll be a virtual conference. But we're hoping to run our Reinventing Space conference on the 28th to 30th of June as a full-blown conference at the QE2 Conference Centre in Westminster. The call for papers for both these events is out now, and details are on our bis-space.com website. I'll tell you more about them at the end and our future lecture program if I have time. Today we are again using Crowdcast system for both the presentation and the Q&A. It worked well last time, so let's hope we have a trouble-free session tonight. Please use the question system to ask your questions anytime during the talk, and as most of you know, you can also vote for those questions you most want to hear and ask them, or at least you can click on the vote panel on the question panel. So let's hope you can make that work, and Fabrizio will be taking the questions. So I'm pleased to say that we have tonight an excellent speaker to talk on space and cyberspace, the risk for missions or for future space missions. It sounds fascinating, but I won't say anything more. I'll hand over now to Fabrizio Bernardini, who leads our BIS Italia branch in Rome, to introduce tonight's speaker and to run the Q&A afterwards. Over to you, Fabrizio.
Hello, everybody. Happy New Year to everybody. That's the first lecture we have this year, as Alistair said. And I welcome especially our very distinguished guest, Stefano Zatti. Dr. Stefano Zatti is recently retired from the European Space Agency. And he's basically inaugurating a series of conferences we will do together with people we know in the European Space Agency. They are so kind and share our vision on how to communicate a lot of technical space expertise to people. So Stefano is also a good example that you don't have to be an aerospace engineer to work in space. Stefano is a mathematician, and he went to work first at Berkeley University. Then he went to the IBM Research Center in Zurich, Switzerland. And then he landed in ESA for a lot of years. I think it's about 23 years, if I will remember, Stefano, something like that.
Actually, 26.
26, thank you. And where he finished his career, and he's head of the, let me read it because it was complicated, the head of the security office, which actually was based in Rome. And I will let Stefano tell a little bit what is why the European Space Agency has a security office when we work in space, which is very important, and that is also part of the topic of this discussion. Now, Stefano is retired and he's holding a master program. He's working in a master program, and he teaches cybersecurity at the University of Rome, Sapienza. So Stefano is up to you. We are listening to you, and of course, I recommend, as Alistair said, to people to post your questions. The system lets you also vote the questions, so we can start selecting the most interesting questions for everybody. Have a good evening, everybody.
Thank you very much, Fabrizio. I'm introducing my presentation by, okay, can you see it?
Not yet. If anybody has problems, please use the chat to communicate with us, and we will read the chat. Okay. Yes. We see the screen. You have to click to close the message after the yes. Okay.
Then I see an infinite disappearance.
Yeah, this is strange.
So if you just minimize Safari, Stefano, then we'll be viewing your presentation.
Can you see it?
Yes. Yes, you have to go. You have to go in presentation mode, probably.
Yeah, this I'm doing. Okay. So if you can see it, I start.
Yeah, for me it's perfect.
Okay, so I'm going to talk about the protection of space missions with some experience coming from my tenure at the university. Universities now. At the time, I was head of the security office of the European Space Agency for 12 years. But before that, I was actually responsible for the security of the IT systems. Meaning that the fundamental issue to be addressed is the protection of space missions, and this is what we're going to be addressing. First of all, we are going to talk about what a space mission has to do with security. Both in terms of what can be derived in terms of security for the European citizens out of space, and then what are the threats that can face a space mission in terms of denial of some of the fundamental functions that the mission has to accomplish. So we will see this with some detail, but then we will go into the analysis of the cyber threats of the space missions. So not only we talk about threats that can occur and can affect a mission, but we will see more specifically what are the cyber aspects, which are now becoming increasingly important, although they are not the only ones, but they are becoming increasingly important because of the increasing pervasiveness of the cyberspace in everyday's life, and in particular in the activities related to space. We'll go into some analysis of the countermeasures and draw at the end some conclusions. Let's first start from what I said before, the elements of security and space that derive from the ESA Council. There are basically two aspects related to security, to how security can affect the well-being of European citizens. Security on Earth, spacecraft and space missions affecting and providing information relating to threats on Earth, and then security in space, which we'll see in the next slide. Security on Earth can be affecting critical infrastructure protection, because from the satellites you can observe and obtain data that are related to the status of infrastructures on Earth, maybe water supplies, agriculture, hospitals, fire protection, also transportation, bridges, ships. Maritime surveillance is related specifically to the trajectories of ships and to the possibility of threats related to ships, like icebergs or floating devices, floating even not only in ice, but also, I don't know, containers that have been dropped and can be dangerous. So all of this can be observed from space and determine countermeasures that can be enacted. Land surveillance, the same thing can be done on land. It's related to agriculture, but it's also related to movements of people, possibly also of troops on the surface, but also support of humanitarian crisis and rescue tasks in crisis situations. that can benefit very much out of space observations. Public safety, including civil protection, and other emerging security threats like, for example, climate change, which will be the subject of a presentation by my colleague Parinello in one of the next meetings. And it's particularly of interest in these days. Then, as I said, there's also the other aspect, which is security in space. Observing from satellites other satellites or other objects that are in space, like near-Earth objects, can be asteroids, can be meteorites, can be debris that can be affecting other spacecraft. Space weather, which is phenomena related to not to the atmosphere, but to above the atmosphere that are still affecting the Earth and other spacecraft orbiting it, like, for example, cosmic rays, and then satellite tracking. So spacecraft watching other spacecraft. They can be active or can be inactive, but they can be constituting threats to each other. So this is the basic framework where we're moving. Looking at the future, in the Horizon 2020 programs, there are two key orientation areas related to space. The key orientation area is the terminology of the focus, defining the focus area of the Horizon 2020 program. New services from space. We will see this also in the conclusions, how space can be used for benefiting citizens, European citizens in particular, but all Earth citizens, for their well-being in different aspects, beyond the ones that we have already considered, and then how to make the space sector globally competitive. So to maintain a lead in our industry with respect to other components on the Earth, and to maintain it competitive. So this is the fundamental question that we're going to be facing today. Is space secure? And this question can be articulated in both aspects that we have seen. The aspect of security of the space mission, so maintaining the integrity and the properties of the space missions, and then deriving important data from space. Because as we will see, most of the threats are coming from Earth. We are not at the moment considering the possibility for threats to be coming from other civilizations. We cannot exclude it in the future, but for the time being, we haven't seen that. The threats are coming from other bodies that can be asteroids or meteorites, but can come mostly from Earth and from actions coming and originating from Earth. Here we start with some examples of hacking, spoofing, and spying in space. We look at the unclassified data, so we look at the press, and we already can see that there have been examples of interventions related to the integrity of the space missions. For example, starting in 1998, a German joint German-American satellite called Rosat, a telescope, turned inexplicably towards the sun. And if a lens goes toward the sun, the sensors get damaged. And so there was a critical optical sensor, and this was irreversibly damaged. And this was due to a cyber intrusion that took place at the Goddard Space Flight Center that was commanding the spacecraft. Another example, in 2007, it was a Landsat satellite, Earth observation, that experienced 12 or more minutes of interference, which happened again less than a year after in 2008. The responsible party was able to create the interference, but did not achieve full control. Another case of an Earth observation satellite of NASA, AM1, in 2008, experienced 2 events of disrupted control, and the attacker this time achieved all steps required to command the satellite, but did not issue commands. So these were observed events. And this goes on the press. The press is, of course, very interested in echoing these events. And these the same events that we have just mentioned were amply covered by the press, with some attribution. Chinese hackers are suspected, but not really proven. It's very hard to attribute these events. But then the people in the organization get contacted. And here is another example in ESA where I was the one who got contacted. This was in 2011. A hacker calling himself ThinkCode was able to gather control of some servers of the European Space Agency, as well as of CERN. And then the journalists call the responsible communication people. The communication people don't know what to say, and so they call the security people. And so everything happened, fell on my desk, and then I had to make declarations and to first of all, to investigate what has happened, and then to try to see what was to be done. And of course, these events reveal weaknesses. Here is another example, more recent, Christmas 2015, there was an attack by Anonymous where data of the European Space Agency were hacked and published. And these were a lot of accounts. They were actually not fundamental, but this is never a good excuse, as the one who was responsible for the accounts who said, oh, it doesn't matter, this was all outsourced. The fact that some responsibility for operations of a service is outsourced doesn't mean that the responsibility, the end responsibility, doesn't come to the end target, who was the European Space Agency. So it's not possible to go to the journalists and say, oh, don't worry, it was an outsourced services, nobody cared. On the contrary, the European Space Agency gets affected and gets in the news, and we had to admit as a policy the attack and to react to it as quickly as possible. Other impacts by different categories. We introduced the categories here because it's very important for what comes later. Navigation, observation, telecommunications, navigation satellites. There was in 2010 a software update of the GPS ground segment impacted up to 10,000 military receivers, and this was just a software update. So it was probably non-intentional, but with a heavy impact. And a group of students in 2009 at the University of Texas were able to spoof a GPS device. And we know the GPS device was later spoofed, an American drone was spoofed by the Iranians, who gave a wrong signal, sent to the drone a wrong signal, forcing the drone or convincing the drone to land in a land that was actually Iranian. So it was simply telling it a different position, a wrong position, so that it landed. In Earth observation, there were interference and control loss that we have already mentioned. And there was also a viral attack on the ISS, infected with a virus called W32, because a cosmonaut, you know who the cosmonauts are, brought a compromised laptop aboard without proper antivirus screening. Deliberate jamming of telecommunication satellites, Arabsat, unauthorized access using cheap DVB cards and using open source software during the Balkan War. So we have plenty of events, and we have actually many more, but not all of them gets published. And let's go to the concept of cybersecurity and see how the two things come together. What is important from the quotations that we have here is the definition of cybersecurity, which goes a bit beyond the concept of information security, of which many of us with some age are used to. Cybersecurity is a more modern concept. It goes in technical terms, preservation of confidentiality, integrity, availability in the cyberspace, but it also talks about security safeguards, guidelines, and risk management approaches, which is what I'm going to focus on the following. And it's also what I'm teaching at the university. Risk management as the methodology to handle threats and to counteract them with proper countermeasures. Now, who is target of the cyber threats that are affecting our operations? Government, aerospace industry, telecommunications. The government are targeted by state and non-state sponsored actors. We are not going to say much about who these states are, but it is clear that there are threats coming from states' interests looking for intelligence on foreign affairs and diplomatic and defense networks. And the targets politically are foreign defense ministries, international operations, as well as military. For aerospace, which is what we're interested in, there is a high visibility, motivation is visibility and impact, and we look more at motivations after looking at threats. And the target are space missions, their data, and the space assets. For what telecommunications are concerned, state-sponsored actors from China, Russia, and the West target EMEA firms that are from Europe, Middle East, and Africa. Motivations include obtaining information, obtaining technical leads, and the target are cellular mobile carriers, IT business services, telecommunication devices, as well as satellite operators. We have seen plenty of this in the past, in the recent past, and we see it increasing. Who are behind these threats? Most of the threats are perpetrated by outsiders, but a good quarter of them involve internal actors. There are criminal groups that are actually entering in the cyber threat arena, but a minority, about a fifth of them, are conducted by state-affiliated actors, and 5% are multiple parties. So they are involved partners combined to 5% of actors. And the tactics, most of the breaches include hacking. 81 of hacking is related is leveraged via stolen or weak passwords. One wouldn't believe how easy it is to break into a system, even with today's strong measures. Malware, more than 0.5% of the breaches include malware. 43% were social attacks, which means basically phishing. And errors were causal events in some of the breaches, including privilege misuse. Now we go specifically to the aspect of space missions, and we analyze the function of a space mission and the threats that can affect the space mission. Now, what is normally a space system? I don't know if you can see the arrow. A space system is composed, a space mission is composed of space elements that are put in space and normally orbit the Earth, but can go also far away. There is a ground segment, which is composed of a control segment. For ESA, this is ESOC, the Center of Operations, that will be addressed by my colleague Paolo Ferri in one of the next presentations, and a user segment, which is normally on the ground. Users are on Earth, and they benefit out of the mission. There can be very, very broad communities, like, for example, the Copernicus mission of ESA offers free and open data to everybody. So there is a very broad user community. Now, the control segment, the control center, will issue telecommands to the space elements to give them orders about things, what to do, positioning, and as well as operational orders. In return, the space elements return housekeeping telemetry, data about the status of the positioning and the status of the spacecraft. And of course, they provide the payload, which is the function of the mission. The payload can be a lot of data, can be positioning data, which is not a lot, but it's very precise, very accurate, but the payload gets then shared with the users. in different ways, all related to the data policy. And this also affects security, because the data policy will have to protect the properties of the data. Now, what can happen to the mission? This is also called the study of the feared events in terms of risk management. What is it that the mission managers don't want to happen to their mission, to their spacecraft, and to their data? Space debris is a typical threat. There's thousands and hundreds of thousands of objects up in space that can collide with our satellites and with each other. And this all needs to be traced, space situational awareness, and protected from. There can be actions to disturb the communications at the electrical level between the ground and space, the uplink jamming. There can be, this is easy to do, to replay or to counterfeit the telecommands. Why is it easy? Because the telecommands are normally known to the public. Their syntax, how they're being put together, they can be counterfeited and can be replayed. So, for example, if we replay a telecommand and we say to a satellite to turn 90 degrees, and then we repeat it, then the turn will be 180 degrees. So without the proper protection that we'll see next, it is quite easy to replay the telecommands. Easy if we have a ground station, but then we will see the telecommands or the telemetry can be intercepted. If the payload is open and free to everybody, it's not important that it gets captured, but maybe other properties can be affected. So open communications lead to open availability of the data transmitted. And there can be unauthorized physical access to the ground. Both the control centers or the ground stations can be threatened in one way or the other. There can be social engineering applied at the level of the ground stations, at the level of the control segment. And then the data can be hacked on the ground at the level of the dissemination to the users. Hardware can fail, and then the whole of the network and the system on the ground can be affected by cyber threats, basically by the traditional attacks, malware, social engineering, SQL injections, all the different attacks that can be relevant to the properties of information assurance of the whole system. Now, what has become increasingly, what has been increasing in the latest years is the fact that the cyber threats can be applied without having access to the ground stations, physical access to the ground station, without having access to a big antenna. They can be applied from our offices, from our homes, simply by hacking into the systems with classical hacking techniques like the one we have just mentioned. So the space, the footprint of the attacks has enormously increased because of the pervasiveness of the cyber world. Now, why on earth would one have to threaten what in one individual would have to threaten a space mission? Are they doing any bad? Are there any opposition to the space mission? It can be competitors, possibly by means of third parties, paid third parties, looking at information and knowledge, bridging gaps, technological gaps that clearly make the different space organizations. There can be cyber criminals that can be after some kind of financial gain, for example, ransomware. They can obtain compensation out of releasing data that they have hijacked. There can be internal employees that can be non-properly trained, negligent, or having motivations for open hostility. This is true for every organization. It's not necessarily specific to space missions. There can be activists, politically and socially motivated to hamper space advance. I often refer to a specific case that happened in ESA a few years ago, when the whole of the mailing system, the email system of ESA was brought down by an attack, the distributed denial of service attack by animal rights activists, because they were meaning to defend the animals that were used in the space station, because there were some news that the space station hosts animals. These news were actually some kind of inspired by past missions where chimpanzees and dogs were used sent in space for tests. But in the case of ESA, there was not such a use of animals. The DG, the Director General, who was Dordain at the time, had to intervene and make a public declaration saying that there was no animal in the space station and experiments were run exclusively on human beings. And there was no complaint about that particular aspect. It can be nation states, information, looking at information, strategic advances, and then testing new types of attacks, including cyber warfare. There is an example in 2007, there was a kinetic attack by a Chinese towards a Chinese satellite that was destroyed, and it was destroyed by another Chinese satellite that was just made to collide, forced to collide with it. This was not a good idea because it created an enormous amount of debris, but it demonstrated to all of us that this can be done. And with the wrong will, it can be done. Then there can be terrorists, motivations of political, religious nature, aiming at critical infrastructures on Earth, but affected via space. Not directly, so there's no laser beam that would be beamed from space into some of the critical infrastructure, but it can be counterfeiting information or making it fake, like, for example, the case of the Iranians deorbiting the American drone. Now, what damage can be done? So we saw the motivations, and then let's look at the damage, at the effects. The effects that can be to a space mission, we saw it in the pictures before, that can be tangible by counterfeiting the telecommands. The spacecraft can be made change trajectory, can be made focus on another target. That can be different observation. The whole mission can be hijacked, and the device can be deorbited or moved to another orbit, or can be simply made unoperational, thus adding to the problem of space debris. But there is another aspect which is fundamental. When you saw the examples that I gave you before, you can imagine the damage that can be done to an organization, to the reputation, to the image of an organization, when it goes on the press by saying that it doesn't properly protect the data of its collaborators. So the reputation can be enormous. And so that security needs to be introduced also to protect the integrity of a mission, also in terms of reputation. And then the data can be stolen. This is all depending on the data policy, but if we have a data policy which is strictly protecting aspects of the data, like the confidentiality or even more the integrity, can have heavily impact the mission. What is the first element of the countermeasures? We'll see the countermeasures, but the fundamental element that we need to have to enact any possible countermeasure is to put a chip, a crypto chip on board. The crypto processor will enable the activation as well as the activation of protection measures in terms of encryption, in terms of integrity checks, in terms of serialization, counter, all of this by being put on board before the launch, of course. Now, one could say that the same kind of algorithms could be implemented via software. And this is possible. The platform computer could contain some software primitives that could implement some security. But this would be expensive in terms of space and also electrical budget. So the idea of having a crypto processor which can be bespoke or can be even commercial, if properly shielded on board, would allow the implementation of the measures that we are going to talk about in a minute directly by hardware with a very efficient processing power. This is a picture. I'm not going to dwell too much on it, but it's very important. It's a quotation from the CCSDS communication architecture. The CCSDS is the Consultative Committee for Space Data Systems, which since 50 years meets regularly and is composed of representatives from all the world space agencies. There is a security working group, and the security working group has identified the threats, and these are the same ones that I have mentioned in the simplified pictures before, and also identified the different contexts that can be affected by these threats. A relay satellite, a satellite itself operating specific functions, different agencies, different universities, different ground facilities, how they can interact and how they can be affected by the threats that we have mentioned: jamming, replay, data traffic analysis, data modifications, and so on. So this generic architecture is providing additional details with and different components with respect to the scenarios that I mentioned before. But then let's go back to those scenarios and see in a simplified fashion, so that it can be brought at the level of this presentation, the countermeasures and controls can be implemented to protect from the threats that we have seen in the previous slide. For what concerns the space element, redundancy is the measure. We can create different satellites. For example, Galileo has 26 different satellites in different orbits. They can provide additional availability by creating more of them, constellations, but also situational awareness, knowing where each one is and where each one is going in a clear and very defined, very deterministic way, so that we can be really safe and sure that everything is known, and measures can be taken, evasive measures can be taken to avoid potential collisions. Then, in terms of cryptographic possibilities, the telecommands as well as the telemetry can be authenticated. So without the need to make them secret, we can make them protected, authenticated, so that utilizing the crypto chip, we can authenticate them, we can protect for their confidentiality, we can protect their integrity with media access control codes. The data itself, the payload data, depending on the data policy, can be encrypted, can be protected, can be authenticated, can be integrity checked. And to do this, we have the additional problem, which is as old as mankind, the problem of key management. When we have an encryption, even Julius Caesar had his Caesar cipher, which is transposing the alphabet. But there is a key involved. How many letters we use to transpose the alphabet. When we have an encryption, of an algorithm for encryption, we need to make sure that the two parties share a key. And these keys can be stored on board, pre-stored on board before launch, or can be organized in a hierarchy. There is a whole different lecture that we could have related to the management of the keys. But fundamentally, we need to be able to modify the keys in time when a sufficiently big quantity of data has been transmitted. For what concerns the ground, the cybersecurity needs to be applied end-to-end: physical, personnel, and the classification of the data, which we will see in the next picture, which is this one. end-to-end cybersecurity 360 degrees. We start from the physical perimeter by zoning the areas where the servers are. And this is actually the moment to answer the original question of Fabrizio, which was, what is the function of a security office in the European Space Agency? The security office has been, under my leadership, and it still is, following and even increasing its function, ensuring the fact that the security of the systems is addressed in a 360% fashion. Physical protection of the ground areas and where the data is processed, access control for all the data centers, including access inside the same area. So different zoning of the different locations. Personnel, building a relationship of trust with the people that are dealing with the missions, with the data, in making sure that the different behaviors are checked, and if necessary, depending on the classification of the data, if data is classified, there is a need to obtain particular levels of clearances for some key personnel. Classification of the data, which can be formal, depending on European legislation for classified data, but also informal in classified, unclassified areas where still data has a very high value, sensitive value, for example, commercial value, technological value. And all of these can be applied. And the search and the assurance of the properties of information, so-called information assurance, which is protecting the information, the confidentiality, which is normally done via encryption, the integrity, which is normally done via media access codes, availability, which is normally achieved via redundancy, and proper backup of data, authenticity, which is identity management, identifying positively the people who are involved in the actions, cross-checks, access control, signing the data with the proper means of authenticity, and non-repudiation, which is the confirmation that some data has been sent, some data has been received, and this is normally achieved via certificates. Now we come to the point of characterizing the space missions, because after having said this, the set of measures that we want to apply, we need to ask ourselves, do all missions have the same requirements for security, or are there differences between the different missions? So the first thing we do to answer this question is to characterize the missions in a tree of different families of missions. And then we will see what are the threats that affect each one of these mission categories. So we have human, so manned missions, unmanned missions, and launchers that are at the top level of the characterization. Human missions have to do clearly and mostly with the space station, but we are witnessing additional horizons in these missions, including the moon, including Mars, and whatever. Space tourism, manned in-orbit infrastructure, and exploration of the different planets. As you can imagine, this has a very high requirement in terms of integrity, because we want to make sure that the lives are properly preserved. Launchers can be, of course, of different measures, small launchers, medium launchers, heavy, big launchers, as well as those launchers that have humans in them. We see Falcon 9 in the recent developments. And then of the unmanned space missions, that are still some that deal with safety of life. Navigation, because the positioning of the Galileo devices can really affect the well-being of humans, as well as Earth observation, because the weather forecasts or surveillance, as we have seen before, the land surveillance, maritime surveillance, have real impacts on on the safety of life, as well as in terms of communication, communication missions, of which there are many aspects like TV broadcast, telecommunication, backhaul, as well as direct communication. They can really affect people's lives. Then we have the whole set of the scientific missions, interplanetary, microgravity, observatories. Maybe they have less impact of life, but they have strong requirements on authenticity. They want the data to be genuine. They want the data to be credible in order to build theories. All of this, as you can see, characterizes the mission with different security requirements. We have already seen the picture: scientific, Earth observation, navigation, meteo, manned space flight. They have different security requirements. At this point, when a security office like the one that I was leading needs to be addressing the requirements, what do you do? Of course, one could say every mission is taken differently and is treated differently. But if we want to do it in a systematic way, we can consider different families of measures and group them in profiles. And then to say that specific missions will have to consider a specific profile. Let's look at these 5 different protection profiles that affect or applied to telecommands and telemetry and data and payload data, applied to the different mission categories, respective mission categories. Let's start from profile 0. Profile 0 has no specific security. So the only thing that is done in profile 0 is the physical protection of the terrestrial links, including standard cybersecurity measures that are to be applied because of simple best practices of IT systems: firewalls, intrusion detection systems, CM, which is the security infrastructure event manager, observations, keeping into account what is going on the Earth. And this is not different from any other organization on Earth. This is implemented historically in the first missions, the Earth Explorers and the Earth ERS and MBSAT missions. So this is the past. Now, the first two profiles with some security. Profile number 1 is static telecommand protection. The telecommands are authenticated and sequenced, so they have numbers, so that you can't replay it. You cannot say turn 90 degrees if you have already said turn 90 degrees, because there is a number inside the telecommand. The authentication keys are preloaded on board, and there is already on board the crypto processor, unless you want to do the encryption in software. The telecommand authentication can be enabled or disabled with a command by ground if there is a critical situation, or automatically by a timer or by a watchdog if the critical situation leads to the need to disable the encryption in order to make clear commands to recover the satellite. This is always the case. This is a must of the mission planners and the mission managers. They always want to be able to disable security when there is an emergency situation. It's the same story with the firemen that come to deal with the fire, and they need to have access, and sometimes they ram into a door, or they break a door because they need to intervene and to do their duty. This profile 1 is currently implemented on METOV and on METOP, on the meteorological satellites, but also on the ATV, which is the automated transfer vehicle, of which I think four or five instances were sent to the space station, and they had done the encryption by preloading 4,096 keys on board and using these keys for each one of the different sessions. Then there is the profile 2, where the telecommand protection is dynamic, which means the keys are changed. They can be modified, and they can be updated. The telecommand authentication and anti-replay are implemented. The keys for the authentication are loaded by the ground using master keys that are loaded. So the master keys, they are not 4,000, they are much less, but they are preloaded and they're used to generate and to load, upload session keys that are used only at specific intervals or epochs. The telecommand authentication, as always, can be enabled or disabled by ground or via a timer if there is a critical situation. And this is implemented in the Sentinels, which are the spacecraft of the Copernicus mission. Then we can go to more sophisticated profiles. Profile number 3 is dynamic telecommands, but also with the payload data. So there are 4 types of keys, one of which is used to encrypt the data. But since the data is heavy, is bulky, then it can be necessary to modify, to refresh the keys on a regular interval. So there are keys, the master keys preloaded, authentication keys for the telecommands, payload data encryption keys, as well as the encryption keys for the telecommands. As before, the payload data encryption can be enabled, disabled as well. And then the most sophisticated profile, profile number 4, which has the dynamic telecommand protection, the payload data protection, as well as the protection of the housekeeping telemetry. And for this, we need 5 types of keys. They are all managed via the preloaded master keys. So after all of this, we will have to ask ourselves, and this is actually the essence of my course at the university, what profile should we choose? And in general, what is the level of security that we want to implement in our system, whatever it is? Ground, space, business, defense. We need to perform a security risk assessment. In the specific case that we are treating, a cybersecurity risk assessment, using methodologies that are well established and even standardized. I quote the ISO 27005 standard, which is articulated in 3 phases: risk analysis, risk evaluation, risk treatment. In the risk analysis, we identify the risk and we make a quantitative estimation of it, analyzing the threats, the vulnerabilities, the likelihood of an event, and the impact it can cause, and then measure it in such a way that we can then lead to an evaluation, to a comparison of the risks with the criteria of evaluation that are part of the organization, intrinsic to the organization. In the case of the space missions, the criteria would be related to the categories of the missions, whether they're scientific, they impact humans, they are dealing with classified data, and whatever. This would lead to different decisions taken by management. So the decisions are not taken by the risk assessors, they are taken by the executive management, and they have to decide how much money to invest and what kind of measures to enact or not to enact, accepting the fact that the risk can be occurring, that the impact can be materializing, and then countermeasures or disaster recovery measures would have to be taken. The options for this would be mitigate the risk, investing and taking actions, avoid the risk, basically changing business. We avoid the risk by not doing a particularly risky or dangerous action, accept the risk and be ready to take measures if it happens, transfer the risk by taking an insurance. So this is the fundamental core of our message, of what we did in ESA, what we do in the university today. Assess your risk and take the measures depending on what you are prepared to accept, which is normally called your risk appetite. The example that we can provide is the Sentinel security baseline. The Sentinels, there was a working group maybe 10 years ago, considering all the different possibilities of a Earth observation mission relating to the monitoring of the environment and of security, basically what became the Sentinels. And the profile 2 was selected, dynamic telecommand protection with some additions, telecommand authentication with the sequencing for anti-replay. The telecommand encryption is limited to the telecommands that are bringing up new keys. Encryption only for the telecommands themselves. Payload data and housekeeping telemetry would not be encrypted. Payload data is open and public because of the Copernicus regulation for everybody. A small number of pre-installed fixed master keys used as key encryption keys. Session keys uploaded by ground using master keys on a regular basis, on a regular interval. Keys referenced by master keys referenced by meta information, avoiding the need to encrypt the telemetry. Authentication bypassed automatically by a timer, by a so-called watchdog, depending on critical situations. When the mission is under critical terms, then it could be beneficial to disable the encryption. And as well as bypassed via authenticated telecommands that would be clearly protected. Now we come to the conclusion. The conclusion is looking at the future, is looking at the current situation and where we are going. Cybersecurity of space missions is a matter of competitiveness for the European space industry. This is one of the key factors of the Horizon 2020 programs. Keep European industry competitive. And to do that, make the missions secure. And this is vital for the EU, which is, of course, very keen on this, because they are the owners of the Copernicus and Galileo programs. They are the sponsors. So they want to see the European industry competitive. Now, the need to guarantee high production rates, for example, when you have a constellation of 1,000 satellites, how can you produce them so quickly? Well, you need clearly to purchase equipment off the shelf, to purchase industrially produced equipment. But what kind of guarantee do we have in the supply chain? We need to include new component providers that can come from new countries, and we need to insert them in the chain of trust. And this is quite difficult. You can see every day the discussion about the 5th generation of telephony, of communications, and most of the providers are coming from the same country, and the trust that we can put in this provider is the big question mark. And we need to develop certification schemes, which is actually what the current European legislation is doing, in order to make sure that these pieces, these components of the chain are properly confirmed and certified. And this is the globalization of manufacturing capabilities that I just mentioned. Commodity software and hardware has expanded the opportunities for malicious modification, and the critical functionality could be thus compromised. And this introduces additional risks that we need to face, and that's where we are looking for the future. Okay, so this is the end of my presentation, and I try to recover the visibility of the faces, and then I'm eager and available for any questions that I think Fabrizio will moderate.
Yes. Okay. Thank you, Stefano. This is very, very extremely interesting, and I was forcing myself not to comment on certain aspects since I work in telecom and control of satellites and telemetry. And I was in fact wondering, asking you what is, because for sure this has been discussed, what is the impact of adding crypto processors and these technologies to satellites, how they can impair testing, because testing and validation of the satellite is very complicated. But of course you answered me, because this you can disable that. So, and I saw that in the different option there is the capability to disable the activity, because to remind everybody, Usually, the two things, doing a system which is very safe, secure, more than safe, secure, at the same time making it easy to manage, are that two conflicting requirements, because we try to do things as simple as possible, but of course this is adding layers and layers of complication. And but of course there are solutions for this, and I'm happy to hear that it's on the Sentinel. This is an active system already, and also I wanted just to clarify, maybe for other people that may not be completely aware of this, the standard for communication with satellites are public. It's important that it's like this. It's like the internet. So the internet protocols are completely public, otherwise the internet will never work. It's the content of these protocols, so the messages we exchange, that are a little bit more proprietary. In ESA, there is a wonderful telemetry and telecommunication standard called the Packet Utilization Standard, which is also pretty common to all the missions. But the way you implement it, it becomes peculiar sometimes for a specific mission. Some things are standard, some things are less standard. So it makes it a little bit more difficult for people to try and understand how to control a satellite. The documents that contains all the information how to control satellites, they run hundreds of pages long, and for a single satellite there can be a few thousand pages of information just for a single satellite. So it's difficult. However, modern technology, but even older technology, let people to listen to communication. And listening to communication, you can learn a lot of things, because if you happen to be close to a ground station, you can listen to the entire traffic if you want. And of course, these protection systems are for this reason. Am I correct, Stefano?
Okay, so it's, there was, I imagine that this was a question.
No, it was not really a question. I was just adding something of my own, because I
will make a comment to your comment, going in a few different directions. So the first thing is the fact that the data is complex and is bulky, thousands of pages, does not make it secure.
I agree.
We learn. I mean, all the security people say you cannot have security through obscurity. And the adversaries are clever, are brilliant. We are not dealing with idiots. So they would be able to penetrate the syntax of commands if they could do it, and if they wanted to do it. So what we need to do is to create security using the existing protocols. And this is what has been done even at the level of TCP/IP in history. You use fields in the packets that can be utilized, exploited, and these fields can contain security data. For example, you create a media access control for integrity, and you plug it into a field which is available in the header. And this is something that we did in Berkeley 40 years ago, 35 years ago, by putting security. And this is also something that we did in IBM. Exploit the fields, and these fields can give you the properties of integrity. The properties of confidentiality need more encryption, because you need also to protect the data where the data is held inside your payload. So it's a bit more complex, but still you will not encrypt the headers of the traffic because they need to be routed through the network. So these techniques can be not easily, with some effort, but can be applied. And this is actually what the CCSDS Security Working Group has done. They have created a number of instances of the usage of encryption protocols, typically AES, the Advanced Encryption Standard, in counter mode, in different block modes, whatever. But they have basically enhanced the space link extension, which is the basic satellite, the basic protocol to collaborate between different ground parts, all the way end to end to the spacecraft. And allowed to make it secure. But then is where you need to address with the mission managers the requirement that these features can and shall be disabled if necessary by specific commands, protected commands, so that only those who are entitled can disable them, to face situations of emergency where it is necessary to do without them because there are additional or higher levels of risks affecting the mission. So security can be inserted, can be, let's say, added to existing protocols with some tricks, and can also be opted out in particular situation if necessary.
Yes, I liked a lot when you have the full reset of the satellite, when we go maybe in safe mode, the security is, of course, is disabled, just to simplify the recovery process. The fact that we use common standards is also important for this emergency situation, because all the ground stations on the Earth can talk with basically any satellite because of this standardization. So it's very important to recover mission when something funny happens. And maybe this can be discussed also with Paolo Ferri in the next lecture, which is, of course, he can tell stories probably about this kind of situations.
Yeah,
so,
many stories.
Yes. Stefano, I go to the questions now. So I have the first question voted by a lot of people. He says, the question is from Peter. Do you believe that the new private space companies are sufficiently meticulous with their security? If not, what should they be doing better? Talking about private space companies.
Okay, now the question is, do you believe? So this is what I believe, because I haven't been following directly by meeting them, these companies. But what I believe is that they are particularly keen on the security of their own services, as a bank would be. They need, it's their image, it's their reputation. If there is an attack on SpaceX or on Blue Origin, and this is known and goes to the press, this is basically getting them out of business. So I think that they are particularly aware of the risks that they are facing, including the fact that they are bringing humans to space, so that the risks are not only in terms of security, but also in terms of safety, as you have already introduced. But for them, it is fundamental to use technologies and methodologies like the one that I have outlined, and to make sure that everything runs smoothly. Remember that security people always say the biggest success of security is when nobody notices it exists, because things run smoothly. Security is inadequate only when bad things happen. If good things happen, it means that nobody is even aware.
So instead of saying better safe than sorry, it's better we say better secure than sorry.
Yeah. There is a big discussion. There has been years of discussion on the different aspects and implications of the two words safety and security, especially because in some languages these words are the same.
Like in Italian.
Which is extremely confusing, because it would mean if we say black and white with the same word in a language, these are completely different concepts, and they actually not always go together. When in explaining courses, we say that security is to prevent one from coming in. Safety is to allow somebody to get out. So it's two different directions. Safety, you let people evacuate. Security, you don't let people in. The example of the fireman with an axe is often taken in this context.
Exactly. Okay.
Next question.
Next question. And Elizabeth, okay, thank you. So this question is from Benjamin. How common are attempted cyber attacks on space missions? Are the defenses you've talked about mainly a matter of preempting potential threats, or are actual cyber attacks common, imminent, and ongoing? What is the most serious publicly known successful cyber attack on a space system that has happened so far?
Well, I mentioned some of the cyber attacks.
Indeed.
So, I mean, there are others, like Stuxnet, which is not which is a cyber attack, but is not on a space mission, is on a power station. But I would say that the cyber attacks are increasingly pervasive, and in terms of space, some we have mentioned, some we don't know because they are hidden. But definitely this risk exists, and it needs to be counteracted, especially at the border, firewalls at the periphery, at the perimeter of the space missions.
I don't think we have the information, but do you think that the military missions can have more interest from cyber attackers?
Well, this depends on the geopolitical situation. If countries are facing each other, confronting each other, definitely they will attempt all possible ways, and the cyber is the most most vulnerable at the moment. We know that there is this unit of the People's Liberation Army in Shanghai. There is even a picture of this building 10,000 something, which is a division of the armies, whose militaries are all cyber experts, many of which are trained in the West. And their goal is basically to build scenarios of attack and to exploit them, without being caught. I said the attribution is always uncertain.
Yeah,
because it's very difficult to gather evidence.
This is very disturbing. Okay, let's go to the next one. Okay, so we have a question from Dario, that you know him. He says, apart from the issues related to the crypto security and the integrity of the communication with the satellite and the ground stations, are there any actions planned to evaluate and protect the authenticity and genuinity of the elements that are part of the spacecraft payload included, which may have been developed by external third party and suppliers?
Okay, this is a very good question, and it has a clear impact. Now what I can say is only based on my memories of ESA and on my current academic profile. But from the memories from ESA, I can really outline the importance of protecting the technical information which is entrusted by industry to ESA as holder or organizer of missions with multi-vendor. It is extremely important that the knowledge which is entrusted to ESA, which is running space missions, by industrial partners who are providing technical knowledge and technical excellence, it is fundamental that this is kept and protected, because we cannot, it's not like you put everything in a big cauldron and you melt everything together. These elements of knowledge are proprietary. And this is why, with a big effort, already in 2008, with the first version of the ESA security directives that were then repeatedly updated, there was a concept of protecting unclassified information. Because the fact of having proprietary information from industry is fundamental, and it's fundamental that industry trusts ESA, which was not always the case. And so the fact of utilizing protection means for authentication, for key distribution, especially for confidentiality and for integrity, but I underline in this particular case confidentiality, needed to be applied also to unclassified information, which does not provide legal protection. It's not a crime, but it's a breach of contract. So it provides contractual, legal protection in terms of contractual obligations. This was a big feat, a big enterprise, and required also technical measures to be implemented.
Okay, thank you. Next one is from Stephen. And are standard cybersecurity framework sufficient for space missions, or should there be space-specific frameworks? He is mentioning NIS, ISO 27001, etc.
Yeah. So the framework, the ISO standards are the ones that were applied. You know, the mission operation infrastructure, the MOI, of which Paolo Ferri will, to which Paolo Ferri will refer in his presentation, was certified for ISO 27001 in 2014 already. So the methodology is the one mentioned and being applied. The NIS as well, the NIS came later, but it was relevant in the context of cooperation. So all of this is the basis to start from. But then when you run a certification exercise for the appropriate standard, the content of the exercise needs to be customized for space, because we are not talking, we are always talking about data, bits. We are always talking about protecting measures in cryptography. But then, for example, when you need to put a crypto chip in a spacecraft, it needs to be properly shielded. Otherwise, it will burn with cosmic rays. So all of this needs to be addressed specifically, but these are just additional threats. And as such, needs to be addressed as part of the same kind of framework or methodology. For example, when we certified the system, the MOI, the people who came to do the certification, the auditors, were from BSI, British Standards Institute. They were not space experts, but they were very keen on asking questions about whether particular threats had been defined, analyzed, and counteracted.
Okay.
So the answer is yes. The answer is this methodology is what is being used also for space, but tailored and customized.
Of course. Thank you. Now we have a questions which has been detailed kind of answer. No, can you oh, I can do this. So there was a question from where it went. I lost it. No, because somebody voted it out. Sorry. There is a question which is pretty generic. I know how to answer that, but one of our members, Gianmaria, which is also, let's say, very keen on these topics, already answered. The question is, which programming language is used for the software of satellites? Which is the safest? I have my own opinion on this, but please, Stefano.
This I don't know. I haven't been involved in the development of the software for the satellites. I've been involved together with Mariella Spada and Daniel Fisher. I've been involved, and we actually wrote a paper many years ago about the methodologies to be used to develop safe software. But then you can use any language. So this level, I don't come. I'm not going to this level.
This paper you have to send me, because I have to send also to Gianmaria, our member is going to. So please remember, you have to send me this paper.
Yeah. I can send it.
I can answer a little bit about that. My opinion.
It's a long time ago. Long time. I think it was.
Don't worry, the software never gets old. So I can answer this very quickly in the sense that it's not a matter of language. Language is really the bottom part of the software development process. And as already Stefano said, it's more important how you develop software, not really. The language is any language is good. There is no religion war. The major software programming languages used in satellites are C language, C++, ADA, but a few more, but that's it. There is some discussion of including MicroPython for onboard sequences, but there are also alternatives. And so it's more important the compiler for safety, not more than security. And they must be qualified. The operating system or executive must be qualified to be sure that it doesn't get in deadlock, for example. But then Gianmaria, which is our is also a cryptic expert, not also a cryptographic expert, but also a cryptic expert that provided also a very long answer to Domenico. Domenico, feel free to send us your email if you need more clarification on these topics. No problem, we are here for that. Okay, going to the next questions. Now one is being voted up from Stephen again. And are standards for TT and C links a benefit or a risk for security? If a hostile actor knows the format of the commands being used to control a satellite, does it make it easier to spoof commands?
This is a very good question, but I already addressed it, answering your first question.
Yes.
So, in my opinion, you know the debate about open software, Linux. Microsoft kept saying in the past that the fact that the software is open is a weakness, because everybody can program and change the system and spoof it and modify it. But then if you keep secret something, it will be leaked. So the good methodology about cryptography is to keep secret the keys, not keep secret the system, including the algorithms. In these terms, the fact that the standards are open so that the telecommands can be constructed and uploaded is a weakness, as we saw in the presentation. But this can be avoided, as we discussed with Fabrizio earlier, the fact that there is a possibility to use fields to make the different commands secure. So the syntax is known. A field of a few bytes can be exploited, and this field can be protected and protecting the whole of the packet. So in my opinion, it's always good to be open with the knowledge of the systems and to keep the efforts to keep and to focus the efforts to keep the keys secret.
On behalf of all the engineers, I thank you formally, Stefano. This is very important for engineers.
Yeah, listen, there were discussions in the past, especially with people with military background.
I can imagine.
Because the people with military background prefer to keep things secret, but they have the advantage that they can take people, put them on the wall, and shoot them. Whereas in engineering and in ESA as well, this is not an option that we have.
Yes, because sometimes engineers want to fire somebody, but we are not allowed to do that.
Yeah.
Okay, question from Stuart. Is there a bigger role for government regulation to play in improving cybersecurity practices across the space sector?
I would see the government playing a role in improving the security standing of the people, of the citizens, because for me, cyber weaknesses affect the freedom of the people. So there should be actions by governments to protect and to ensure that the normal citizens are protected from the big brother. You know, there was this big discussion about applications tracking the contagion of the COVID virus, the coronavirus. So this is where I would put the concern. For the space mission, I would see more the collaboration of the space agencies. And the CCSDS is an example because it's working very well. It's very fascinating as an effort. But it's since the space agencies some are national, some are international, some defend specific interests, some are more defending the industry. I would see more the effort in the collaboration for the definition of security frameworks in these international terms, rather than specific for the government. Whereas the role of the government is what I mentioned before.
Okay, thank you. So the next one is, sorry, let's start with the mouse. The next one is from Sean. As we seek to increase the autonomy within space and across the segments, what further cybersecurity challenges do you envisage?
This is what I had in the last slide. So what I envisage is the need to ensure security in the supply chain, in the fact that we use components. Imagine that we have to build a wall, and we need to purchase bricks from the furnace next door. We need to have to rely on the bricks, because otherwise the wall will collapse. In order to do this, we need still to ensure that this is done at a reasonable cost. So the fact that there can be weak components in the chain, and just consider the debate about 5G at the moment, is a matter of worry, is a matter of intervention that can be definitely also initiative of the government, relating to the previous question.
Okay. Question from Philip. Is talking about on-orbit routing of communications. This provides a path for state actors to move malicious payloads laterally to other space elements. With multiple countries involved, does this provide a high risk vector to collaboration?
This is not a question. This is a dilemma. Can we trust all the elements of the chain? And for me, the way to trust the elements of the chain is to create certification schemes, like the common criteria, to create communication schemes to which providers can and shall subscribe. At this point, the fact of, and there is another element that we amply debated, the element of dual certification. When you have a certification scheme, it may, the most demanding one, may require different authorities to cross-certify each other, basically gaining access to the source code. And even without having open software, but with controlled access to the source code, so that it can be creating a European stamp that would create trust in a component which would not necessarily be produced by a European company, but would have to be open to the certification scheme. And this is also what the new directive on security, the European Cybersecurity Act that funds, that creates the new role for ENISA and creates a new role for certification within this framework, is aiming at.
Okay, thank you. And a question from Alistair. Looking to the future, we have seen proposals for satellites that provide electric power or energy on the ground. Should they be considered as weapons, as they could fall into the wrong hands, like rogue states, terrorist organizations, or just criminals?
Anything can be a weapon. A satellite that falls, is deorbited and made fall on the White House is a weapon, even if it's a piece of hardware. The 2007 case of the Chinese killing, kinetic kill is called, their own satellite, is a case of using a piece of hardware as a weapon. So all goes down to improper use. Even a hammer can be a weapon. So it all goes down to improper use and proper control of the use of these kind of devices.
Okay. And then we have a question that I think maybe still out of scope a little bit. I can answer it partly, but I give it to you. Is how space debris are monitored?
SSA, Space Situational Awareness. There is a space debris office, Holger Krag, in ESOC, who is dealing with, and every organization has its space debris office, and they are monitored by observing means, like from other satellites, from ground observatories, not only their position, but also their directions, where they're going. But it's becoming increasingly complex because of the of the crowd, the amount of debris which is up there.
Yeah, the question was from Domenico. If Domenico wants a technical on how we do the monitoring itself, this is done by radar, and especially radar on the ground, and that they keep track of debris up to is pretty small size, but not everything, not dust-like or chip of paint things. So a few centimeters at least must be metal, of course, to track them with radar. And there is a database which is kept continuously updated and is, of course, monitored operationally by all the operation centers, of course. It's becoming a problem, of course. It's one of the big problems we have, especially in low Earth orbit.
Yeah.
Another question from Royce. For deep space missions, and also human missions to Mars, the delay in communication with Earth may encourage the use of artificial intelligence. Is there any thinking about rogue artificial intelligence, as for instance HAL in the film 2001? Futuristic but serious question, he says.
This is a very fascinating question. I would not know the answer because it's really looking into new technologies. But I think that Paolo Ferri may have some opinion about that, because he is the one who has been dealing with the Rosetta control, and there were moments where the delay was something like 30 minutes or 35 minutes, so that you cannot take a decision there. You need to pre-program everything, and that's where artificial intelligence would act.
Yeah,
or maybe
I think
misact.
Yeah, I think there is a little bit of, of course, exaggeration in terms of artificial intelligence is a peculiar term. It's not really like virtual reality, but it's an oxymoron for certain aspects. I think getting a rogue AI, now that the AI is only algorithms, it's not really intelligence. So it's difficult, but in the future it could be a problem, of course. But there are other implications about this. The talk of Paolo Ferri is going to be on February 17th, if I'm not wrong. And I recommend everybody to listen to that. It's a very special one. You will know everything about space operation. And please do this question again to him. He's going to like it. And a question from Yain, sorry. Do you believe that we now have unrealistic high expectations for the safety of human space flight in the US compared to?
There were some implications or some kind of innuendos about the fact that safety in the Chinese astronaut field, astronaut corps, are less of concern than the European ones or the American ones. So the feeling is such, but for sure, this is not an excuse to give up our values. For us, always human life will be at the most. And so even though there are implications or some doubts about the fact that how many Chinese astronauts were sacrificed in order to get somebody up in their station, we don't know, and probably we will never know until there is some kind of whistleblower or defector who will tell us. But there is such a feeling that there is less implications on the lives, there's concerns on the lives of some other organization. But for sure, this is not the case in the case of European astronauts or American astronauts. Their well-being is at the most. And also related to the SpaceX, to the Falcon 9 launcher, where safety has been at the top of the priority.
Of course. Thank you. Now, this is peculiar because it looks simple, this question. How do you control the usage of passwords by your staff? From
Well, there was, when I was the head of the security office, there was a video that was, I don't know where I still have it, but there was a video where I was going around doing all possible mistakes of security around the whole site, including talking in the corridors, posting passwords on the screen. Now, the traditional way is to use a password checker when the password is changed. So to subject the selection of the password to a specific predefined rule, which is 8 characters, diacritics, symbols, lowercase, uppercase, numbers, and so on. This is traditional. The modern way to do authentication to the system, which is actually something that I worked in IBM in the 80s, is the concept of single sign-on, where a weak secret is traded with the system. The secret could be biometric, can be voice, can be a challenge back, but anyway, one gets into the system, and then strong secrets are used to authenticate at the different other steps, the so-called single sign-on. And the weak way to get in is evolving. Now, for example, in Italy, we have a system called SPID, which is authentication via callback or via strong authentication, means dual factor or even three factor, in order to get in contact with the public administration. For example, to pay taxes or to pay the salary of employees and so on. So the concept of the weak password is, although, as I said, it's the weakest point, the #1 attack vector, is hopefully going to improve with technology, with additions of access means.
Okay. And next one, this is from Alessio. Alessio is a good friend, and beware that he's working also as a spacecraft controller in DLR in Munich. Regarding interplanetary missions, so which were and are the TMTC security profiles? Because he also added a note, it could be critical for Earth gravity assist maneuvers.
Okay, this I don't know, because it would have to be answered by the respective mission planners. I developed the methodology and the solutions, but then it depends on how it gets implemented.
Okay.
I would say to use 3, so to go beyond the Sentinels if it's interplanetary. But the traditional wisdom is that when the spacecraft goes far, it's harder to reach it. Okay, this is what you need a bigger station, you need the deep space antennas. Nowadays, it's not the case anymore, because you can always inject commands into the deep space antennas by hacking into them.
Yeah.
So that's not the case anymore. It needs it's more in the direction of the delay tolerant commands of the question on artificial intelligence.
Okay, and I have a side question to this then. If this cryptographic add-ons, let's call it, do they add to the data volume, or they are equal data volume? Because that's critical for deep space mission when we exchange bits per second only.
Yeah. If you use the existing packet formats, as we were discussing before, you can't make the commands bigger, because the space is the one which is already predefined. So you need to exploit fields. A counter field, for example. There is always a counter field in the command. There you can put the encrypted part. So the crypto chip will provide a sealed contained byte or 2 bytes, and this will be hosted inside a field which is already present in the command, in the packet.
Okay. And then we have Nigel from London who would like to know if Hamming code is used for additional encryption.
What is Hamming code? I don't know it.
Well, it's close to Nigel. The modulation schemes, they use Hamming code, but they also use other methods. So basically, there is already a kind of encryption which is built in the fact that we use complex modulation systems. In fact, we work in a QAM or other similar things. So I don't know if I'm replying to you. But yes, these are, of course, more than additional encryption, maybe it's a layer of complexity that makes attacking the system a little bit more difficult, of course. So I hope this answers your question, because I think the last one is from Alex. How closely does ESA work with other agencies on security? Do agencies simply trust each other's security, or do you have to prove to each other that your security is good? Are some agencies better than others?
Okay, this is a question that should be answered by my successor, because it's a question about now. What I can tell you is that in the past, until I worked in ESA, which is 2019, the end of 2019, one thing was the cooperation with the member states. And this was done formally via the Security Committee. And it was extremely positive, extremely rewarding and also, I would say, successful, because there was a very strong collaboration at the European level to make European missions secure. For what concerns the other agencies, there was, in my time, strong interaction with NASA, in particular by exchanging details about the security of the respective missions. With Canada, we established a security agreement with Canada, and that's it. I went repeatedly several times to Russia, but I did not have meetings or contact with the Russian authorities. I had contacts at Star City with the European astronauts being trained and launched there, because remember that for a long period only Soyuz was the vehicle to send astronauts up to the space station. So this is all something to be still defined. There were several attempts to build a security agreement with Russia, there were a lot of discussions and also a lot of scenarios, but this didn't materialize. So maybe it's still ongoing on the table.
Okay, so we have done all the questions. So I thank everybody for participating in this, and especially
thank you,
Stefano, for your participation. This has been a very great talk, and if you feel that you want to give us updates, let me know that we organize another events. And
always a pleasure.
Yes, and I would like to give back. I count on you to participate in Paolo Ferri talk.
Oh yeah, of course, and also Tommaso.
Yeah, of course.
Okay, well, thank you very much for an excellent talk and answering so many difficult questions. It reminds me of the day I arrived in a satellite operator's office in the Middle East somewhere, I won't say where, and it was 2 days after they discovered that someone had been using one of their transponders unknown to them for about 6 weeks.
Mm-hmm.
So it was before we understood the word cyberspace. So that was back in about 1989. So that was a long while back.
Yeah, I have a lot of stories about hacking and misuse of telecommunications in those years.
Yeah,
your needs.
I don't think there was any sort of security system on the uplink, and people were able to use transponders without anyone else knowing.
Especially because they were analog transponders, so you just send up a signal, it's routed back to Earth. And
yep,
that's right. 2 governments got into trouble for that, but I won't go into details. Thank you also to Fabrizio for asking all the questions and to making sure we had a good run of questions too.
I apologize for my English.
Oh, I think we understood, and we could read all the questions anyhow, so that was fine. I think the system worked well, and I'm hoping we still seem to have 126 people on board, so that's great. And I think really it's time to thank Elizabeth also for coordinating the whole event for us and making sure we behave ourselves. She has reminded us that we only have 15 minutes to finish off, so let's try and do that. Thank you again for being with us, and before everyone goes, I'd like to remind them that we do have another talk, and I think Jerry Stone is probably in the audience here. He's going to be talking on the 3rd of February about the Apollo 14, A Walk in the Highlands. Jerry Stone is a long-time fellow of the BIS and a space presenter and educator. And I think he's probably going to be with us this evening, and I hope will be with us on the 3rd of February. On the 18th of February, by the way, it's the 18th that we have down in the books for Paolo Ferri. Until recently, he was head of operations at ESA. He'll be telling us all about ESA flight operations, so we're looking forward to that. Now, going to the other events, the big Beyond the Moon symposium on the 12th of April, the call for papers is now out. We want to look to the future. Starting at the moon, we want to know where to go next, and we want to know how to get there and how to survive getting there, considering the 10 barriers that were highlighted in Jerry Webb's recent article in Spaceflight: radiation, extended flight times, lack of gravity, self-supporting habitats, infection, mental survival, and the reliance of machine intelligence. And also we want to understand the economic, socio-cultural, and political religious effects too. So plenty of room for papers. We should have about 10 or 12 papers in the day. So looking forward to more to come in. We've already got some very good ones coming in. Now on the 28th to 30th of June, the Reinventing Space Conference, we still hope to be able to run it at the QE2 Conference Centre in London. And we want to concentrate on the environmental and sustainability considerations in relation to space, including protecting our own environment and space debris. So papers on that welcome. And also we want to look at the space support for the economic recovery in the post-COVID-19 era. So that's quite a wide-ranging seminar we've got there. And finally, can I remind everyone that we actually have the Sir Arthur Clarke Awards running at the moment, and the nominations actually opened on the 2nd of November, and they should close on the 1st of February. So if you've got anyone that you feel should be recommended for an award, there will be 8 awards, and we will probably have to extend this for another week or so to get some of your own nominations in. For details, please look at the website, bis-space.com/Arthurs, and that will get you straight into the details and also the nominations page. The 2020 awards will be actually presented at the Reinventing Space Conference dinner at the QE2 Conference Centre on the 29th of June. So hope to see you all there. Anyway, I must now thank you all for participating and let you go off and have supper. I'm sure it's well past your supper time in Rome, but we look forward to seeing you next time. And thank you very much for a most entertaining evening. Cheers.
Cheers. Thank you.
Thanks a lot. Grazie, Stefano. Thanks a lot, Stefano.
You're welcome. Grazie.
Bye-bye.
Okay. Goodbye, all.
Bye-bye.